Hi guys, do you have same problem with this audio analyzer? I find something about this and I want to share with you guys. In here, my audio analyzer's outputs, all outputs are connected to all oven inputs. It's just connected to itself. There is no any other device under test. My all settings are correct. I set to my generator one output to 1 kHz 12 dB volts RMS output. My input alternator setting is correct, but it says ADC overflow, but it's not. In this window, everything is going crazy. It's everything is false. Everything is wrong. This noise floor is ridiculous. There is no 1 kHz sine wave tone also. It's basically not working. And if you will little bit more wait, you will totally lose USB port connection with the PC, and it's just totally stop. You need to unplug and replug to analyzer, but this thing is happening again. It's basically not working now. And there is no problem with my PC's USB ports or USB cable or anything, because everything works great on my PC. Only this audio analyzer is not working. Okay, now I'll show you what I find. Okay, this is what I find inside QuantAsylum Audio Analyzer. I open this device and immediately there's an unpopulated capacitor take my attention. This capacitor is right beside of the USB port, and this capacitor is connected to directly ground between 5 volts supply rail. It's basically a supply bypass capacitor, but it's unpopulated. If this intentional for a reason, or it's just a basic serial manufacturing mistake, I don't know. But it's very suspicious to me, and now we will check that 5 volts voltage rail with oscilloscope. Okay, before looking at 5 volts rail, let's check my setup. This is my only 200 megahertz bandwidth oscilloscope. I'm laughing because this 200 megahertz bandwidth is ridiculously low for looking there. If you want to know what's going on here exactly, you need to very expensive a few gigahertz bandwidth high-end oscilloscope, and plus you need very expensive a few gigahertz bandwidth differential probe for looking there, but this is what I got. Firstly, this is my oscilloscope's channel 1 yellow trace on the screen. I'm using this short ground tip. I don't know if you can see. Yes, I'm using this short ground tip. This is very important. I cannot use long ground wire for looking there. This is first important thing. And second thing, this is approximately 13,000 AL factor, high permeability, UNGAP ferrite toroidal core, and I did 3 turns. This is approximately 118 microhenry common mode balance choke. This is very important for filtering high frequency common mode noises. This is second important detail. And also I'm looking at common mode current with my Licroy AP015 current probe, because there is an unwanted ground loop coming here, and little bit DC current is flowing on oscilloscope's probe ground. I want also check that DC current loop. Okay, now we can look at 5 volts rail. Okay, now my oscilloscope's channel 1 vertical scale is 200 millivolt division, and I set to AC coupling. Channel 2 vertical scale is 100 milliamp division, and I set to DC, of course. This is ground loop, common mode ground loop current, remember that. I'm using 10 megapoints memory depth. This is maximum memory depth of this oscilloscope, and I'm using longest capture time as possible on this oscilloscope. And we have 2 gigasample second real-time sampling rate. First things first, we need to check how much good or common mode rejection. For this, I will short my oscilloscope's input and connect to QuantAsylum's USB port ground. Firstly, I connect my oscilloscope's ground pin to USB port's ground, and I short it now. Yes. Very good common mode rejection. As you can see, there is almost no any false common mode noises on the signal, and little bit over 200 milliamps DC current is flowing on the oscilloscope's ground. I connect my current probe backwards. Don't pay attention to that. Everything's okay. Very good common mode rejection, or common mode rejection coil is working great. Okay, now we can look 5 volts rail. Now I connect my oscilloscope ground first. Whoop. And QuantAsylum is stop. Yes. Now QuantAsylum Analyzer lost USB connection with PC. I'm connecting 5 volts rail now. Yes. Wow. Look at this noise. This is very dirty, very noisy 5 volts rail. I stopped the waveform. Wow. Approximately 2 division, 6 division, 1.2 volts approximately noise we see here, but probably this noise way worse than as we see in here, because if you because this oscilloscope's bandwidth limit only 200 megahertz. If you looked at signal with 2 gigahertz bandwidth oscilloscope, probably you will see way worse than this. I just check noise shape, and I want that spike measure how much frequency. This is probably over than this oscilloscope's bandwidth. I also open cursor, horizontal cursor, and I must be very gentle, because sorry guys, this using this oscilloscope just a pain. Very slow user interface. I want this spike. Zoom in. Wow, look at the spikes. These are big problem. Little bit more zoom. Little bit more, yes. Now I want to know this spikes and man, this is pain. Oh, nope. Slow. Gentle. Yes, 182 megahertz. Wow. Yes, we can't see this spike's real shape on this oscilloscope, because it's way too over. In here, if we check this here, 196 megahertz, 200 megahertz. This is very high frequency for this oscilloscope. This means this noise way worse than this. Now I will mount a bypass capacitor, and we will check this waveform again. Okay, I did mount a 1 microfarad 50 volts X7R capacitor, and also plus 4.7 nanofarad 50 volts NP0 capacitor parallel to USB ports voltage rail, and I did not change any settings on the oscilloscope. All settings are same. And firstly, again, I'm checking common mode rejection now. Just make sure everything's okay. Yes, there is no any false common mode noise on the signal. Common mode rejection is very good. Now I'm looking to 5 volts supply rail. Yes, this is way better than old. Now I stop the waveform. Open a zoom window. Yes, this is way better than old. Yes, this is way better than old. and it works now. We fixed the problem. All settings are same on the software. All measurements readings are correct. Spectrum is correct. Everything works great. But there is another important problem with this analyzer. Second problem is USB connectors contact resistance, I believe, because if you touch the USB connector, just a little bit move the connector, after that immediately audio analyzer's PC connection is lost, and you need unplug and replug again. For fixing this problem, probably I will make another external DC 5 volts supply input for this analyzer. But today's video is finished. I will make that external supply input, and I will share with you guys. Thank you for watching.